Eric Burgess here, and we are told to sketch an angle theta in standard position with least positive measure, find the 6 trig functions. And then we're also told a coordinate point, and this is going to be key for us sketching the angle. So first, let's go ahead, let's sketch this angle. So I'm just going to draw out an axis here, and the easiest point of starting is to just sketch that point. So we've got a y-axis, we have an x-axis, and we've got the point -24, -7. So I'm just going to sort of randomly put down -24 over here and -7 right here. This is a -7. And so the point would land right around there. We simply draw a line to the origin and we put down an angle and we have to label it. So we'd start at the 0-degree line and we'd go to our angle. So we call this whole thing the angle theta. And boom, you've sketched it and we've drawn it with the least positive measure. If we drew theta going this way, this would have negative measure. So theta is being measured this way. If we drew it the other way, going clockwise, we'd have negative measure. So it's important that you label it correctly. So from here, we notice that we've got a triangle on our hands. We've got a triangle. It comes from here, goes across like this. There's this triangle in there that we've defined. So let's go ahead and draw this triangle a bit bigger. So we're going to have something like this. Right, not quite to scale or whatever, but you get my drift. So we're going to have -24 right here, -7 right here, right? Because the distance we came down going this way is the same that we came down going this way, because we define this to be -24, -7. It's not to scale, so it's probably a good idea to label your points just to show explicitly what that point is. And so, okay, so we've got these two things, and all we're missing is the hypotenuse, which we call r. It's going to come from circles. You'll be learning that in a while. But if you were to take this line here and spin it around, it would trace out a circle. Not that that looked like a circle, but it would trace out a circle. So we call this r for the radius. And so we say, okay, well, let's look at this. We've got r, and we know by the Pythagorean theorem, right? A squared plus b squared equals c squared. We sometimes also call this c, but you'll start calling it r a lot more. So we're going to have -7 squared. And don't forget to put this in parentheses. If you have the negative on the outside, you'll get all screwed up because the square will only do the 7. Plus -24 squared is equal to r squared. And if we solve this, we'll get r. Now, this actually is what's called a Pythagorean triple, meaning that all the numbers for each of the side lengths will be integers. It's kind of a cool like thing to go and try and find Pythagorean triples, but this will actually end up being 25. So we can really quick do this. Let's go ahead and turn our calculator on, and we're going to have 7, and then we're going to square it. You can drop the negatives because they're going to go away from the squaring, so you can just ignore those. Plus 24 squared, and we're going to get 625. And then we take the square root of both sides to get r. So we take our answer. So we go second square root. And we put our answer in there. Or you could type the number 625. And we get 25 out. So we get that r is equal to 25. So this is what r is. It's 25. And knowing this, we can finally deal with the angle theta. So theta, right, started at the 0-degree line and came down like this. And we called this whole thing theta. And we can look at it in the triangle and we could say, okay, well, sine of theta, if you recall from your definitions, that is going to be equal to the opposite over the hypotenuse. Or we call the opposite, right? If we look at what's opposite, that's going to be this side over here, which this is the up-down coordinate. So that's the coordinate y. It's going to be y over r. So an r, because that's what r is here, and that's the hypotenuse of the triangle. That's what we called it. You're going to see this one quite a bit going forward. And so if we plug these in, we're going to get -7 over 25. And we have just found the sine of theta. And if we check it, right, we know that if we have a coordinate system, all students take calculus. And so sine should be negative in this one because only tangent and cotangent are positive in this third quadrant. So us getting a negative for sine makes perfect sense. Now cosine of theta, well, that's equal to adjacent over hypotenuse. Adjacent, also the adjacent angle in this case is this right here, which is the x coordinate. So we're going to have x over r, and that's going to be negative 24 over 25. We just plug in x and r, and we get it out. Beautiful. Now we have, so that's sine, that's cosine. Let's do secant. So secant is just 1 over sine, right? Secant theta is equal to 1 over sine theta, which is equal to, it's just the flipped version of this. Because if sine theta is y over r, if we did 1 over y over r, we're going to get out the reciprocal r over y. So it ends up having the effect of just flipping the fraction. So we're going to have r over y. And the reason for that is if we have y over r, we have to multiply by the reciprocal to the top and the bottom to simplify the fraction. So we multiply by r over y to both the top and the bottom. These all simplify to 1, so we get 1 on the bottom. And 1 times anything is itself, so on the top we're left with r over y. So that's why whenever you see something like a 1 over something, it has the effect of just flipping the bottom, if the bottom's a fraction. So that's r over y. So that's just going to be the flipped version of our sine result. So that's going to equal, let me move this calculator further over. That's going to equal 25 over negative 7. You can move this negative all around. You could also simplify the fraction if you want, but I'm just going to sort of leave it at this. So, okay, we've got secant. Let's find cosecant. Oh, I have made a mistake here. This should be cosecant. CSC. My apologies. Now we're going to have secant. Because the cos don't go together. That's how I remember it. There's actually, it has to do with the angle that you're measuring. But the way I remember it is the cos don't go with it. So if you have sine didn't have a co. So cosecant goes with sine. Because it doesn't make sense to me, it makes sense to me, if that makes any sense. So cosine has a co, so it's going to get secant because it does not have a co. So secant theta is just going to be the flipped version. It's going to be 1 over cosine theta. And this is going to be equal to 25 over 24. And we're going to have a negative there. And that's going to be secant theta. Now our last one is tangent theta. This is equal to, I always think of rise over run. So we're going to have the opposite over the adjacent, or y over x. This is the one that controls rise. This is the one that controls run. So y is, what was it? It was negative 7, and x was negative 24. And tangent, according to all students take calculus, is the only positive thing in the third quadrant. And look at this. We get a positive result out because the negative simplified is 7 over 24. And so cotangent theta, that's just the reciprocal of tangent theta, which is going to be 24 over 7. Again, you can simplify if you want to. But there you have it. So it's not too bad. All you do is you just sketch it. You just sketch the point and then draw a ray to that point. And then if it tells you the least positive measure, you draw in the positive direction. And as soon as you hit it, you stop. If it tells you the least negative measure, you would just go the other direction and then make sure you label it. Just drawing the ray is not enough. You have to label the theta or you probably won't get points for it. You got to show it on your chart. That's what makes it a sketch. Then we just take this triangle that we've outlined here and we sort of blow it up so it's easier to work with. And we solve for the missing side. And using the 3 sides in our sketch of theta, we find the trig identities, we find the trigonometric functions. We find the trigonometric functions by using simply the triangle in their definitions. So another thing, I'm showing the y over x definition things and using the reciprocal identities. And we justified why these are just the flipped versions. But another thing that people use sometimes to remember is SOHCAHTOA. So they'll remember this acronym, SOHCAHTOA. So this is sine, cosine, tangent. And then O is, so this is opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. And so that can be used as well. That will totally work. And the reason is y over r, this works when we're looking at the angle from a position of a coordinate axis like we have right here. But if I were to move this angle to down here instead and call this theta. Now, I'm just doing this to demonstrate that y over r wouldn't always hold. And the reason is if you look at it, if this was theta, well, sine would be the opposite over hypotenuse, which would actually, in this case, be x. So it wouldn't be y anymore. It would be x over r, opposite over hypotenuse. So you can always trust these definitions, but if you're going to use these, you have to be measuring your angle as if it were at the center of a coordinate system like we have here. And this is so common. We use angles this way so much that some people learn these, and I happen to know them, but I'm almost always going back to opposite over hypotenuse, and I just kind of have it memorized. I just look at it and I say, oh, this is what the sign would be. But when you're new, it may be helpful to know that SOHCAHTOA. So tangents opposite over adjacent, cosine's adjacent over hypotenuse, and sine is opposite over hypotenuse. And I use this for a long time. Eventually you do so much trig, you just you start seeing it everywhere you go. So you don't have to remember this particular acronym to do it. But there you go. That's how you do this. If you have any questions about this, let me know. I know when you're starting out getting back into trig, it can be a little overwhelming remembering all these definitions, but very necessary for the things that we're going to be tackling in the next couple chapters. Subscribe, and we'll catch you in the next problem.